Hi everyone, welcome back to Chapter 3 of Data Teach's YouTube series on Introduction to Python. Today we'll be discussing Lesson 2, which is on data types and data structures. So what exactly is a data type? A data type is the type of data that you can use in Python. So imagine you're organizing a box of things, and each thing in this box is a different type of thing. So for example, you might have a book, you might have a computer, or you might have a sweatshirt, and you have to be able to know what each thing is in order to be able to use it properly. So in Python, a data type just tells the computer what kind of thing it's dealing with. So here are some of the data types we'll be discussing today. We'll be discussing strings for text data, integers for numerical data that do not require decimal points, floats for numerical data that use decimal points for more precision, and bool or booleans, which are just the values true or false. So what exactly is a data structure? A data structure is a data type that stores collections of data. So now let's say you're taking your box of things and you're going to organize it within your room. And you might have different objects in your room that'll store different things. For example, you might have a desk to put your computer on, you might have a wardrobe or a dresser to put your sweatshirt in, and you might have a shelf to put your books on. So a data structure is just a way to store and organize this data in your computer so it's easier to find and use. And the most commonly used data structures are lists, which serve as a collection of diverse items, and dictionaries, which map unique keys to their corresponding values. And throughout this lesson, we're going to use the type function in order to check what the data type of an object is. So now moving on to some data types. First, let's talk about strings. So strings are a collection of characters which can include letters, numbers, or even special symbols. And they're surrounded by either single quotation marks or double quotation marks. So now let's look at some examples. On the left-hand side, we created a variable named single underscore quotes, and we set it equal to this string literal that we created using single quotes, and it contains a bunch of letters, it contains numbers, it contains a space, and it even contains punctuation marks like a comma and an exclamation point. And when we check the type of this variable, single underscore quotes, it returns str, which just means string. And on the right-hand side, we created a variable named double underscore quotes, and we set it equal to another string literal, which contains all the same characters and all the same letters and numbers as single underscore quotes, but instead of creating the string literal with single quotes, we created it using double quotes. And when we return the type of double underscore quotes, it still returns str. So we know that it doesn't matter which quotation marks we use to create our strings, it'll always create a string in the end. But one thing to remember is that we have to stay consistent. So if we start a string literal with a single quote, we have to end that string literal with a single quote. And the same applies for double quotes as well. So now moving on to numerical data, integers and floats. So an integer is a number without a decimal point, and a float is a number with a decimal point. And we typically use float when we need more precision with our numerical data. So as an example, on the left-hand side, I created a variable integer underscore value, and I set it equal to the number 32. And I didn't add any decimal points to this number, it's just 32. So when we return the type of integer underscore value, it's going to say int, which is an integer. On the right-hand side, I created another variable named float underscore value, and I set it equal to 32, except this time I added a decimal point, so it's going to be 32.0. And when I return the type of float underscore value, it's going to give us float. So these two variables, integer underscore value and float underscore value, they both store the number 32. However, they're stored differently in your computer because you're going to be using them for different needs. And one thing to remember is that when you do arithmetic with integers, you'll only have a float value returned if you do division. So for example, if I did an integer plus an integer, that'll always return an integer. If I do an integer times an integer, that'll always return an integer. But if I do an integer divided by an integer, that'll return a float value. So to prove this case, let's look at these two examples. On the left-hand side, I have the expression 10 times 2, which we know evaluates to 20. When I check the type of this expression, it's going to be an int, because an integer times an integer will always return an integer. However, on the right-hand side, I have the expression 10 divided by 2, which will return a float type. And this is because 10 divided by 2, we know that value is going to be 5. However, in Python, this will always return a float value. So it's really going to be 5.0. And now let's talk about Booleans. So Booleans represent either one of two values, true or false. And you must spell it this way. So in these examples on the left-hand side, let's say we created a variable named true_value, and we set it equal to the Boolean value true, and we spelled it capital T and then lowercase rue. When we check the type of true_value, it's going to return bool. So we know that true_value is a bool variable. On the right-hand side, however, let's say we created a variable named false_value, and we set it equal to false. However, we spelled false in all caps. When we check the type of false_value, it's going to give us a name error. And this is because we spelled false in all caps, and Python doesn't recognize that as being a Boolean value. So we must remember to spell our Booleans using the same spelling and same capitalization as we see here on the screen. Another thing to note about Booleans is you will either get one of these Boolean values when trying to evaluate an expression comparing two values, which is known as a conditional. So as an example, on the left-hand side, let's say we wanted to print the expression 7 greater than 3. 7 greater than 3 is going to be a conditional, and we'll talk more about conditionals in our next video, but we know that 7 is greater than 3, and this is going to give us the Boolean true, and when we print this, it'll say true. On the right-hand side, we have the expression 7 == 3. And this essentially is just checking to see if 7 is equal to 3, because we know that 1 = is the assignment operator, but 2 = is a comparison operator to see if two expressions are equal. So 7 = 3, that is going to be false, so when we print that, that'll return false. Another thing with Booleans is that we can create variables and set them equal to a conditional statement, and that variable will now store a Boolean value. So as an example, we have created a variable named math_expression, and we set it equal to the conditional 7 less than 3. Now we know 7 less than 3 is going to be false, so that means that math_expression will store the Boolean false. When we return the type of math_expression, we see that it's going to be type bool. Now moving on to some data structures. So first we're going to talk about lists. So lists are created using square brackets, and they can contain values of different data types. So as an example, we created a variable named list_example, and we set it equal to this list here. And how we created the list was we used the open square bracket, and we ended our list with a closed square bracket. Within our list, we have 3 different elements. Our first element is going to be the integer 1. Our second element is going to be the string hi, and our third element is going to be the Boolean true. So when we check the type of list_example, we see that it returns a type of list. And something to note about lists is each element, which is separated by commas, is going to be assigned an index. And they're indexed based on 0-based numbering. So what this means is that the first item in the list is going to have an index of 0, the second element is going to have an index of 1, and so on. And something to remember about that is that the last element in a list is always going to have an index of the length of the list minus 1. You can also subset and retrieve one element from a list with the index. So here is list_example as a reference for our next few examples. And we see on the example on the left, we're trying to subset list_example with the element at index 1. And we do this by typing the name of the list, so list_example, and then we type the open square bracket, and then we type the index of the element that we want to access, and then we type the closed square bracket. So in this example, we do list_example, open square bracket, 1, close square bracket. So we're trying to access the element at index 1, which is the second element, which is the string hi. And something to note about indexing is that whenever you index a list, it's always going to return the value that the element is and not a list. So as an example, when we do list_example and then the index 0, that's going to give us 1, which is an integer. And we know this because when we check the type of list_example, square bracket 0, square bracket, it's going to return a type of int. So this extracted element isn't going to be a list anymore. It's going to be whatever type that value is. And something interesting to note is that you can also subset strings in a very similar way. So as an example, let's say I created a string named greeting and I set it equal to the string hello ! When I try to subset greeting using the square bracket notation, it's going to subset just how we thought it would. So when we do greeting square bracket 3 square bracket, it's going to give us the 4th character of greeting, and that's going to be the character L, and that's what it'll return. So now moving on to dictionaries. A dictionary is a data structure that stores a collection of key value pairs, and they're created using curly braces. So each item in this dictionary is going to have a unique key and a corresponding value, and these two values are going to be separated by a colon. So as an example, we've created a variable named dict_example, and we set it equal to this dictionary that contains 3 key value pairs. The first key value pair is going to have the key name and the value Joe Bruin. The second key value pair is going to have the key age corresponding to the value 100, and the last key value pair is going to be the key mascot corresponding to the value true. And we know that this is going to be a dictionary because when we check the type of dict_example, it'll return dict. So when we want to subset dictionaries, we're going to access the different values using their keys rather than their numerical indices. And keys are typically strings and they have to be unique, so you can't have 2 keys that are the same value in one dictionary, while the values can be any data type and they don't need to be unique. So you could have 2 keys that are different associated to the same value. So as an example, on the left-hand side, we're trying to subset dict_example, and we want to access the value with the key name. And we know that the corresponding value to the key name is going to be the string Joe Bruin. And the same rules apply for the return type of the values in a dictionary. So for example, if we wanted to access the value at the key age in dict_example, it's going to give us 100, and that's going to be a type int. And it's no longer going to be a dictionary anymore. So now let's do some practice. For each of the following examples, please state its data type and why you think so. And feel free to pause the video now and come back later to go over the solutions. So for question A, the answer is going to be string, and we know this is the case because we assigned the variable A equal to a string literal, and we created the string literal using double quotes. For question B, the answer is going to be int, and we know this is the case because we created an expression using only integers and we did not include division. For question C, the answer is going to be bool, and we know this is the case because we assigned C equal to a conditional statement, which will always return a Boolean value. For question D, the answer is going to be string, because similar to question A, we created a string literal, however, we created the string literal using single quotes. And lastly, for question E, the answer is going to be float, and we know this is the case because we are doing an integer divided by a float, which will always return a float. So now let's do some more practice questions. For each of the following examples, please explain its data type and why you think so. For question F, the answer is going to be a type of list, and we know this is the case because we created the list using square brackets, and each value in our list is going to be separated by commas. For question Fi, the answer is going to be string because we are accessing the element in list F at index 0, and that's going to be the string UCLA is the. For question Fii, the answer is going to be a type of bool because we are accessing the element at index 2 in the list F, and that's going to be the third element, which is the Boolean value true. For question G, the answer is going to be a dict, and we know this to be true because we created the dictionary using curly braces, and each key and value is separated by a colon, while each key value pair is separated by commas. And lastly, for question Gi, the answer is going to be a type of int, because we are accessing the value in the dictionary G that corresponds to the key green question mark, and that's going to be the value 35, which is an integer. Thank you so much for watching this video on data types and data structures, and we'll see you in the next lesson on conditionals and loops.